Alright, so add these complex numbers. I mean, I've written them in brackets there, but what you're probably more likely to get in an exam is a question like this one here, where you've got let u be this and w be this, and then find u minus w or w plus u or something along those lines. Okay, but to get our understanding around it, this is what we do. So we're adding. Here's our complex numbers 1 and 2. What do we do there?
2 plus 4.
2 plus 4. We add the real parts, and we add the imaginary parts. That 6 is just the 2 and the 4. The 8 is the -3, and we're adding the -5. Yeah? Next one. Same. 7 plus 1 is 8. I plus -I is
0.
nothing, so that's just
That's
just a real number.
7 plus 1.
Okay, next one.
8.
3 plus 2i. Happy with that? Okay.
No.
No?
3. Not 5. Yeah, 3.
Sorry, did I say 3?
Yeah.
I said 3, but wrote down 5. Right, next one, subtract these ones.
5 minus 2.
5.
How do we do this?
2 minus 4.
We're going 2 minus 4. Here's our real part. What do we do the next part?
Minus 3.
Minus 3
Plus
plus 5.
Minus what?
Negative 3 plus 5.
This is where it starts getting a little bit confusing, eh? Why does it get confusing?
Real.
Because you're dealing with integers and stuff. So what you'll do, and I'm going to get you to do some and show someone an Argand diagram shortly, is when you're subtracting them, rather than subtracting this as a complex number, I want you to change the sort of equation to think of it like adding the negative additive reciprocal, what do you want to call it? It's the same thing, isn't it? Sound right? In other words, I've sort of expanded that bracket, if you like, but I'm adding the opposite. That's a positive 4, it's a -4. It's a -5, it's a positive 5. Now, because I'm adding, it's much easier. That's going to divide by something, that's going to be 2. That's -3 plus 5, that's going to be 2i.
Negative 2.
It's going to be my -2 plus 2i.
Right.
2 minus 4.
That's probably a little bit more confusing than what you're thinking out, but try to think about it that way because it will help you in the long run. So this one here, this is now 7 plus I plus -1 plus I. Okay? I'll just change those two around. She's still recording, but she's not liking it. Okay? So that now becomes 6 plus 2i. Does that make sense? And becomes useful when you're looking at a list, doesn't it? U, -2 plus 8i, minus w. So that's just going to be -5 plus 6i. So that's going to be, oh, that is -2. What is that, -7 plus 14i? Does that sound right? Z equals, yep. You guys happy with that? Pretty straightforward. Okay. Let's now have a crack at some of those questions there. So if I try and show you this one here on an Argand diagram, okay? So this one here. So on an Argand diagram, 7 plus I is there, isn't it? So the vector looks like that there. Okay. I thought that was a plus. Okay, when I'm minusing, where's 1 minus I? 1 minus I is over here, isn't it? Is that right? When I'm minusing, what I do is I change the direction of that vector, and then I add them. So from there, I'm going up 1 and across 1. Like that. So that was at 7, now it's at 6. That was at 1, now it's at 2. Okay? Hence the 6 plus 2i. Alright? Much easier to see with addition, so I probably should have done addition to start with. Show you this one here. You are at 2 and -3. That's where the vector is. You're going to add from there. Thank you. You're going to add 4. So you're going across here to 6. You're adding 4, and you're adding -5. So it's down here. -5. That's going to be 8. So you're adding that vector onto that one, and your resultant vector is your answer. Okay. That's what it looks like. That's what 6 minus the 8i. Okay. You will make a bit more sense of it later on. Okay. Now, having a little look at multiplying ones. How can you multiply those two there? Multiply 3 plus I and 2 minus 3i. How would you do that? With brackets, yeah, with expanding. So 3 plus I, 2 minus 3i. All I'm asked to do now is expand those brackets. 6 minus 9i plus 2i minus 3i squared. What can I do now? The I squared is -1. So this here is now -1. So that now becomes +3, does it not? Yep. So it's now 6. -9 plus 2 is -7.
Funny looking 6, sir. Real funny looking
6 plus 3 is 9. Shush. It's one of those days. Leave me alone, please. There's my answer. Is that right? Please tell me I'm right. Seem right? Yeah. Yeah, no, it's a 9. Did I say 6 or did I say 9?
You said 6.
But I meant 9. Okay. We all understand where the 9 came from, mate. 6 plus 3 is 9. Am I saying that right? Now you guys are stressing me out now. Okay. Try that one there then, please. Try that one there. Example, expand and simplify that one there, thank you.
I literally can't do here yet.
Try that one, come on.
Then take away 2 squared.
Okay, so you've got here, expand this bracket. That is going to be I cubed plus I to the power of 4. Is that right? Is that my answer? No, because I haven't got real and imaginary parts. I've got I cubed and I to the power of 4. So what I need to be able to do is what?
Change I to the power of 4.
Change the I 3 and I to the power of 4 to just I's and real parts. So I cubed. What is that? I times I times I, or in other words, I times I squared, eh? Which I squared is, so that there is -I. Does that make sense? Yep. What is I to the power of 4?
1.
2i squared. So it's I squared times I squared, which is -1 times -1, which is 1. So that there equals 1 minus I. Where the 1 comes from there and the -I comes from there. That sort of makes sense? Can you see that? So this algebra that we're going through now is the algebra is not that tricky, but because we're dealing with something new, it becomes a lot more complex. Okay. So what you're going to do now is try some of those questions just there. Alright guys, what we'll do is we'll move on from these expanding ones, because I feel like if we can expand brackets then we're alright, are we? So what I thought and a couple of questions that do start to get a little bit tricky are these ones here. Okay. How am I going to do that? So, think about this pattern now, and I want you guys to explore this pattern a little bit, because this is all we're going to do now. We're having a look at this I squared and other multiples of I. Okay, so that's the pattern I want you guys to explore. I want you guys to go ahead and do it. So, all right. So the chatter assume means you guys have done it. If you haven't done it, here it is here. The pattern. Is this the pattern here? Like, is it I squared is -1? We all should know that. So I cubed is just I times I squared, which is just I times -1, which is just -I. I to the power of 4, -1 times -1, which is 1. I to the power of 5, well, it's just this one, which is 1 times I, which is, yeah. I to the power of 6 is going to be, it's going to be I to the power of 4 times I to the power of 2, 1 times -1, which is -1. What's the pattern? -1, -I, 1, then I. Every single time. That is your pattern. Okay? What do you notice? Sam, what do you notice? Either or. I to the odd power has an I. There's your real part A. You've got an I to the even power, it's going to become a real number somewhere. Is that right?
What are you doing?
Yeah. Yep. Happy with that? And so you can do all sorts of things on there, and it does get a little bit confusing at times. But to find I to the power of 50, how would you do that?
Well, it's either 1 or -1.
It's either 1 or -1. Yeah, but which one?
It's -1.
How's it -1?
Well, I to the power of 48 would be 1.
Why would I to the power of 48 be 1?
Because it's a multiple of 4.
Because every multiple of 4, when you're saying every multiple of 4, I to the power of 8, I 12, I whatever, is going to be your standard I. Yep. So that's going to be 1 times -1. That's what you said, eh? So in other words, you're going to go 50 divided by 4. That'll give you an idea about how many times it goes into that number. Okay? Where'd the 4 come from? The pattern is 4 long, isn't it? I is I. Okay? Everyone happy with that?